King Collegiate High School, and I'm a junior right now. So for my starter project, what I have here is a light-seeking robot. If you listen to what I just said, it's a light-seeking robot. It seeks light. So there are many different components that go into this robot, but to keep it simple, basically the voltage comes from here, the battery pack. So basically there's a current going through here, and it's controlled through a series of resistors and transistors. Now what actually controls this would be these two things right here. These are LDRs, or light-dependent resistors. They'll change resistance based off of how much light they sense. So that's kind of what makes it like light sensing. So if someone turns off the light right now, actually let me turn this on first.
You want us to turn the light off?
Not yet. Okay. So as you can see, it's okay. So it was sensing light. Okay, you see, now that the light's on, it's sensing light. Okay. So it's moving right now. It's in a moving form. It's not working very well because this is carpet. But if I would just show you right here, if I block this, you see this light, it turns completely off. So this motor would just stop moving. If I block this light stops completely. If I block both, then everything would just stop working because there's no light sense. So basically, oh yeah. So by covering this, it'll turn. By covering this, it'll turn. So basically that's how my light sensing robot works, and that was my STAR project. I worked like a week on it so I could learn a bit about robotics. And I wanted to learn about robotics because my main project is this. This is a 3-wheeled omnidirectional robot. This is like most RC cars out on the market. It could go forward, left, right. What's different from those is this can go in all directions. It can go here, 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 without having to turn, because these are omni wheels. You see, they can turn forward, but they can turn on the side through these rollers. Now, this is just really hard to make. I understood nothing about circuitry, but through these 5 weeks I learned so much. So basically, this right here, this is an Arduino Uno, and this is basically what controls the entire system. It has all the coding and it tells the robot what to do. This right here, this you cannot see it, but it's a 7.2 volt battery. It controls these motors right here. And the thing that completely controls the robot would be this PS2 controller, which I have hooked up, and it's connected to this receiver. So I have basic coding set up. It's still kind of rough, but I think I can get to move. So if I were to move the joystick, so if I were to move the joystick, you see these two move forward. If I were to move it back, you see these two move back, right, left. So I can try running it down the aisle right now. This is still kind of, I can't even see it, but it's still kind of rough coding, so it may not work perfectly. But as you can see, it is moving. They would go up, down, right, left. The controls aren't perfect, so it may kind of spaz out. And as you can see, I just hit someone's chair. So I still have a bit of coding to work on, but it can still move around. One thing I forgot to show. This not only has directional movement, but also supports rotational movement. If I could just get that to work. Okay, that's not working perfectly. But the main idea is to get all motors moving at the same direction, so it'll go in a clockwise sense or a counterclockwise sense based off of what this right analog stick is moving towards. So that's basically what I'm working on right now. I'm almost done. I'm trying to get this thing completed, and in the future I may try to modify it, adding some ultrasonic sensors, a camera perhaps. But yeah, I built this because I was really interested in robotics and just RC cars. Now, I should probably talk about my struggles and what was really hard about this. Well, first of all, you have to get the wiring straight on. If you don't get the wiring straight on, bad things will happen.
What bad things?
I don't know what bad things. Adam, what bad things happened?
Fire.
Yes, fire will happen. So, like most currents, it needs to be controlled, and if there's too much voltage going through a wire, it's just not going to work out. So that's probably my biggest concern. I didn't know when it was going to set on fire, if it was going to set on fire, but it doesn't set on fire anymore. It doesn't set on fire anymore. But I think right now the main problem I'm working through, and kind of the only thing I'm working on right now, is the coding. The coding requires a lot of knowledge in trigonometry and physics, which I haven't even taken yet, so I'm self-teaching myself. And once I finish that, I should get everything working. And that's my robot. Any questions?
Strap something to the robot so we can help clean the house?
I can. I don't want to.
Is there a potential military application?
Yes. So, this thing, you probably noticed, is pretty loud, but if I could figure out a way to make this like quieter, I could probably put a camera on here. There you go. Second level stealth robot right there. The Mars rover, you hear about those problems all the time where it'll get stuck. There goes $1 million. This is omnidirectional. This is not going to get stuck anywhere.
Target someone with fire.
What?
Target someone with fire.
Ah, yes. It could do that right now if I want to, but I don't plan to charge anyone with fire.
Only strap explosive to that robot and you need to like a little suicide robot is like light on fire.
Yes, we can light on fires. Anything else? Alright, thank you.